Greetings and welcome, friends. My friends here, internet friends, like this class so much, they've got to start the Waddy Math intro with me. It's amazing. They love it. So today we're talking about section 11.00 single O dose, about box and whisker plots, which visually are a way of displaying where my data is, where the minimum, the maximum is, and where it's densely compacted and where it is spread out. All right, so a box and whisker plot shows the variability, although part of it will show a measure of center. It shows the variability of the data set along a number line. All right, and so the first thing, the measure of center that it has is the median. And the median, if you guys recall, is the number that's in the middle of my data when it's arranged in order. So it's the middle number, and if there is no middle number, you take the average, as in the mean, between those two middle numbers. But then I've got a couple more new things going on here. I've got the minimum value and the greatest value demonstrated here. And using those two values, I could look between them and kind of figure out the difference between those would be the range, of course. So you guys perhaps recall that. Think so. And the range is a measure of variability as well. So it visually shows you that. But then I also have these new things, quartile 1 and quartile 3, and mean, by the way, is called quartile 2. And quartile 1, does it tell us here? Does it tell us? I think so. The median of the lower half is the first quartile, Q1. So I would take just the first half of the data and find its middle number. And that's my quartile 1. Now, as we'll see in a later example, I believe, if the median was, if there was no middle number, all right, and I found the median was in between the two middle numbers, then the first half and the second half will include their respective numbers. If the median was a middle number, I would still look at the first half of data as being everything except that middle number. All right, so as far as what is the lower half and the upper half, that's what I would be referring to. But you'll see that play out, I believe, in a couple of examples. So I've got a measure of center, not the mean, not the mode, but the median, middle number, and a visual representation of the following. So let's take a look at example 1. Oh, some backpackers. Oh, internet friends, follow along. Ooh, maybe I can even leave that right there. Will that show? Yeah. Good stuff, good stuff. It says, make a box and whisker plot that represents the ages of all the members of the backpacking expedition. So I'm going to first thing is organize this in order. So I'm going to have 18, I think, is the smallest number. No 19. No 20, 21, 22, I think is the next smallest. Right, 22, I've got one of those there. Another 22. I think so. 24, I think, is the next lowest. Yeah, agree. So I've got to just organize this first, which isn't super great. If I have a spreadsheet, you can auto-sort your data, which is kind of helpful. Let's see, 24, I think I've got, 2 25s, 3 25s, count them. 25. And let's see, 25 looks like 27 is the next. And 28. And it looks like 30. 30. Here we go. So, all right, I think I've got all of them. And let's actually figure out if there's an odd or even number. So 2, 4, 6, 8, 10, 12. So there's an even number of numbers, meaning there is no middle number. Okay, so beware of that. So if I want to find the middle number, sometimes I do this cross-off technique. 1, 2, 3, 4, 8, 10, and then I've got two numbers in the middle. And they, fortunately, end up being the same number. So my median, which I could call Q2, we'll write it both ways, tell you what, that's going to equal 25 plus 25 divided by 2, which is 25. The average of two 25s is 25. in case you're wondering. So that's my median, all right? Ooh, should do it live. I'm getting requests. People want to join the chat channel. Here we go. 18 is the minimum value. 30 is the maximum value. We'll call that Max's number there in honor of my student Max. Represent. And then if I want to figure out quartile 1, I'm going to go from 18 only through this 25. And let's see, there should be 6 numbers here. That 1, 2, 3, 4, 5, 6. And so quartile 1 is going to be the average of those. So 1 is going to be 22 plus 24, right? And yeah, you guys can see. And the upper half, the second half of data, has 2 numbers, 28 and 30. So Q3, I'll write it down even though you guys already know what it is. 28 plus 30 all divided by 2 is 29. All right, so that's how I find my 5 numbers. And we're going to call this the 5-number summary, right? And just like a summary in an English class, it represents the data without giving me all of the data, right? If your English teacher asks you to write a summary and you just write exactly the same thing that they gave you, it's not really a summary. You just kind of copy and pasted a book, and that's not great. Not great. So let's make a Box-and-Whisker plot here. I'm gonna draw myself a little straight edge ruler here. How about you? Did I give you guys a number line? I'm not that friendly, I guess. Okay, all right. So let's see. So if I want to make my Box-and-Whisker plot, I guess it's fine there. Down. That's fine. My lowest number is 18, so I definitely got to have 18 in there. My highest number is 30. I think I could get away with kind of counting by 2s. So I'll have 20, 24, 6, 28, 32. I didn't space it out very good. That's fine. And so now it's time for my Box-and-Whisker. So above the number line, which is, I guess, kind of weird, but notice how, like, we've got the Box-and-Whisker above this number line here. And you do need to label at least some of your points. Note, I eventually started labeling every other. Above your number line, you can start plotting these points. So the minimum was 18. The maximum was 30. Right? So 100% of my data is in between those. My median was 25. So here's 24, 26, so 25. I'm going to draw a vertical line as my median. I'm going to try to be above the 25 there. And my Q1 was 23, right there. And Q3 was 29, bless you. And so I'm going to make this box. Yep. And some whiskers. Yeah. So that's a visual representation of this data. And so what does this mean? For one, I could see that the range of this data is 30 minus 18 or 12, right? It's got a spread of 12. And each of these regions represent 25% of the data. And what I want to point out is that the skinny regions are more dense. The data is more densely packed in the skinny band of this whisker. Also, between Q1 and Q3, it's a little bit dense. But for these other zones here, it's going to be a little bit more sparse, spread out. All right, that the data, all of these represent 25%, right? 25%, 5%, 5%. So if 25% of the data is fitting in this very narrow band between, looks like 29 and 30, that means 25% of my data is fitting between those things, is what it's kind of telling me. And so, let's see, 25%, so 3 of the numbers, actually, yeah. So that represents this, right? 3 of the numbers are in between 29 and 30. In fact, all 3 of them were 30. So a Box-and-Whisker, once again, is a summary of the data. And there's a value in being able to do that because eventually, like especially in your generation, we've got what's called big data. We got, right, millions of numbers, trillions of numbers that are being analyzed, right, simultaneously. And you want to be able to just quickly glance at a visual representation to understand what's going on. That's the benefit of a box whisker. You obviously don't need to add all these little shading things. Whisker? Yeah, I believe that's how it's pronounced. Am I saying whisker weird? Am I? No, I don't hear it, guys. So interpreting a box and whisker. Here we go. Kind of what I just told you, right? 25% or a quarter of the data are in each whisker, and a quarter of the data is on each part of the box. And so that's what, yes, I could combine any two of these regions to get half of the data, or 50%, right? So 50% of the data is in the box. I could say 50% of the data is on this left side of the mean, etc. Yeah, so a lot of the data is packed right here, and then it's a little bit more scarce. Or exactly the same amount of data is in that section, but it's more densely packed. Yeah, I don't have a great way of describing it, but yeah, there's more data between these two numbers than there were between these two numbers, an equivalent gap. That's, I guess, another way I could say. So we've talked about range, which is the highest number minus the lowest number. There's also this concept of IQR, the interquartile range. Kind of has a name there. That makes sense. It is the difference between the third quartile and the first quartile. And right, it represents the middle half of the data. And so that's sometimes helpful for us to be aware of. So the IQR, right, would be this, between this and this, right, is the IQR. So if I wanted to find the IQR for this example, right, the IQR, it's just the range of those, between those two Q1s, Q3s, would have been, so IQR would have equaled, what, 29 minus 23, which is 6, right? So 50% of the data is within 6 units, or I guess it's not within 6 units of the mean, but these 6 units about that median are containing 50% of the data. So, all right, let's keep cruising. Here we go. Example 2, we've already got a Box-and-Whisker. Ooh, wow, this is great. Instead of number of words per song, now we're talking about song length, which these look like they're being measured in seconds. So 300 in seconds, how many minutes is that? 5 minutes, right? 300 divided by 60 is 5 minutes. And 180 is a 3-minute song. And that's what I kind of expected, that sometimes there might even be longer songs that come out on an album, but there's a radio cut of the song where they try to make it kind of like 3.5-minute version, because, I don't know, I guess radio. That's my explanation. Bam. All right. Find and interpret the range of the data. Okay, what's the range of this data? So the range is going to equal 300 minus 160, right? The maximum minus the minimum. So I get 140 seconds is the range, right? So the longest song and the shortest song, oh, these are played by a rock band at a concert. So a single band, right, they're playing their set, and this is the range. Okay, all right. So we're not talking about radio edits in this case. All right, describe the distribution of the data. And you might be like, I don't know what that means, right? But there's lots of little facts that we could say. So let's talk about it. So remember, this is 25%. This is 25%. Right, this is 25 and 25. And so usually what I'm looking for is describe the distribution. Maybe you're going to describe each whisker and the interquartile range, which is what they're going to ask for in a minute anyway. You could just kind of notice any interesting facts about it. They're talking about distribution, so it's talking about how it's spread out, not just where the median happened to be. So I could say, here's a fact. I could say 25% of the songs are between 160 and 220 seconds. Right? Seconds. Bam. I could talk about maybe just the lower 50%. Right? I could say 50% of their songs are less than 260 seconds long. Right? Are less than 200. Right? So really you can just, on like the test, I'm usually just going to say like, right, tell me like at least 3 facts about this that you get from the distribution. And I could say that most of their songs, or like the most densely grouped set of songs, are going to be between 280 or 260 and 280, right? Or I could say 50% of them are between, right, 260 and 300. But I'm not going to write it all down right now. I think that's fine. It's fine. I'm fine with it. I'm going to live with it. So let's see. Interquartile range. So IQR, right, is going to be the difference between here and here. So 280, I agree, minus 220 is 60. Right? So half of their songs, the middle half of their songs, are within a minute of length of each other. Okay, so that's a valuable piece of information. It's talking about how kind of tightly packed that middle half, which I think is a great way to think about it. The middle half, right, is right there. And then are the data more spread out below Q1 or above Q3? So remember, Q1 is not the chunk of space. Q1 is the actual number that is the edge of the box, right? So here's Q1, here's Q3. And the data is more spread out below Q1, I agree. Because 25% of the data covers a larger area. A larger region, I don't know, something like that, right? And then whereas this region is a very short section, that whisker, but it still has 25% of the data in there. So it's like super densely packed here, and then here it's still 25%, but it's spread out. So that's kind of like the way you analyze these. Yeah? You feeling it, Mr. Krabs? All right. Ooh, here we go. We can compare some Box-and-Whiskers. And this is actually going to come into play in a couple sections. Here we go. So shapes of Box-and-Whisker. This terminology, I always want it to be the opposite of this. It kind of annoys me. All right, so if your data is spread out to the left, skewed, we could say is, right, spread out. It tails off this way, but it's maybe like really compact on the right side. So skewed left is when the left whisker is longer than the right whisker, right? Most of the data are on the right side of the plot, right? So from the median here, you see, or actually, I guess right side, I guess, would be based on midpoint. You get a whole bunch of the data is on the right half. Means skewed left. All right. Symmetric is when it's just like kind of evenly repeated there. Actually, let me see. Do I still have? Yes, I do. Here we go. All right, internet friends, take a look at this. So, for instance, the rap song's number of words, I would say, is a symmetric distribution, right? If I drew a line down the middle, it's almost a mirror of itself. Whereas both the rock, and the country music, most of the data is on the left side, and then it tails off towards the right side. So that would be a situation in which those are skewed right? They taper off towards the right. right? It's densely packed on the left side of the graph. So I always wanted it to be worded the other way, but that's kind of the way that you analyze this. So let's take a look at example 3. I don't know how many more examples we got. I don't know. Too many. So yeah, I only spend 1 day on this. I don't think it's too crazy. All right. Identify the shape of each distribution. So these are the test scores of your class and your friend's class. Okay, what is the shape of your friend's class based on these? Oh, wow, I definitely said the wrong word. Okay. What is the shape of your class in terms of its distribution? Now let's see. Yeah, the longer whiskers on the left, so yes. Left. Right? Meaning our data is really compact on the right side and then sparse on the left. Okay? And how about our friend's class? What do we identify the shape of it as? That one's symmetric. Yeah? Because it's kind of evenly distributed. The same number of kids are doing great as the number of kids that are not. It's kind of, right, a mirror of itself. Oh, here's an interesting question. Which test scores are more spread out? And how would you justify that? Okay, so their highest and lowest are farther apart, right? So it has a larger range. Okay. Another way I could say it is, notice the interquartile range for our friend's class is 20, and our class has an interquartile range of 10. So it also has a larger interquartile range, IQR. Range. Yeah. And so yeah, so that's really all we got to do today. We're going to apply this in different ways a little bit later on chapter. But yeah, thanks for watching, internet friends. Tienen un día el más bien del mundo. Bye-bye.